About 4.5 billion kilometers away from our blue home planet is the giant planet Neptune. For many years, it was simply not possible for humans to observe the bluish-shimmering celestial body at close range. This was to change in 1989. At that time, NASA sent the space probe Voyager 2 into space, which provided mankind with the first real images of our galactic neighbor. In our contribution today, we would like to take a closer look at Neptune together with you. In doing so, we will also take a look at some breathtaking photos of the celestial body, which will leave you in pure astonishment that the ice giant Neptune. With an equatorial diameter around 50,000 kilometers, Neptune is the fourth largest planet in our solar system. In terms of its dimensions, Neptune is 4 times larger than Earth, whose diameter is 12,742 kilometers. The mass of the celestial body is even 17 times greater than the corresponding value of our blue home planet. In detail, Neptune is a so-called ice giant. This category includes those giant planets whose masses consist mainly of water, methane, or ammonia. In our planetary system, there are 2 such ice giants. In addition to Neptune, Uranus is also classified in the corresponding class. Contrary to the first assumption, however, the planetary surface of an ice giant is not necessarily frozen. In fact, the corresponding substances are present as so-called supercritical fluids. That is to say, they're in a special state of aggregation in which the properties of liquids and gases are combined physical characteristics of Neptune. Size and mass. With a diameter of about 49,244 kilometers, 30,598 miles, Neptune ranks as the 4th largest planet in the solar system by diameter, yet it is the 3rd most massive. It is approximately 4 times the size of Earth, and its mass is 17 times greater. This immense mass contributes to its strong gravitational pull, which influences the orbits of nearby celestial objects, including its moons and faint ring system. Composition and structure. Neptune is classified as an ice giant, a category distinct from gas giants like Jupiter and Saturn. While gas giants are primarily composed of hydrogen and helium, ice giants like Neptune and Uranus contain significant amounts of ices such as water, ammonia, and methane. Outer atmosphere, composed mainly of hydrogen, helium, and methane. Methane absorbs red light and reflects blue light, giving Neptune its characteristic azure color. Interior. Beneath the atmosphere lies a mantle of supercritical fluids, a hot, dense mixture of water, ammonia, and methane. At extreme pressures and temperatures, these substances exist in states that defy the conventional definitions of liquid and gas. Core. The planet's core is believed to be rocky and metallic, approximately the size of Earth, surrounded by layers of dense fluids. Dynamic weather systems. Neptune's atmosphere is incredibly dynamic, with winds reaching speeds of up to 2,100 kilometers per hour, 1,300 miles per hour, the fastest recorded in the solar system. Its weather is dominated by massive storms and high-altitude clouds of methane ice crystals. Great Dark Spot. Similar to Jupiter's Great Red Spot, Neptune features transient storm systems like the Great Dark Spot, first observed by Voyager 2 in 1989. These storms are thought to be anticyclonic systems, with their energy sourced from the planet's internal heat rather than solar radiation. Cloud patterns. Observations from Earth-based telescopes and the Hubble Space Telescope reveal bright, high-altitude clouds that change rapidly over days and weeks. These clouds are primarily composed of methane ice. Discovery and historical observations. Early speculations. Neptune's existence was hypothesized in the early 19th century due to irregularities in Uranus's orbit. These anomalies suggested the gravitational influence of an unknown planet. Mathematical prediction. In 1846, French mathematician Urbain Le Verrier and English astronomer John Couch Adams independently calculated Neptune's position using Newtonian mechanics. On September 23, 1846, German astronomer Johann Galle confirmed Neptune's existence by observing it near the predicted position. Name and mythology. Named after the Roman god of the sea, Neptune's name reflects its striking blue appearance, which evokes imagery of vast oceans. Moons of Neptune. Neptune is orbited by at least 14 known moons, the most significant of which are Triton. Triton is the largest moon of Neptune, with a diameter of about 2,706 kilometers, 1,678 miles. It is unique because it orbits Neptune in a retrograde direction, opposite to the planet's rotation. This suggests that Triton was a captured object, likely a Kuiper belt object, rather than a moon formed alongside Neptune. Triton's surface is covered with nitrogen ice, and its geysers eject plumes of liquid nitrogen, a phenomenon first observed by Voyager 2. Proteus and Nereid. Proteus, discovered by Voyager 2, has an irregular shape and a dark, heavily cratered surface. Nereid has an eccentric orbit, hinting at a turbulent past involving gravitational interactions. Hippocamp, discovered in 2013 using the Hubble Space Telescope. Hippocamp is the smallest of Neptune's moons, with a diameter of only about 34 kilometers, 21 miles. Rings of Neptune. Neptune has a faint ring system, consisting of 5 primary rings: Gal, Leverrier, Lassell, Arago, and Adams. These rings are dark and made up of ice particles coated with silicate dust or organic material, giving them a reddish hue. The Adams ring is particularly notable for its arcs, or clumps of material, whose origin remains an active area of research. Exploration of Neptune. Voyager 2 mission. NASA's Voyager 2 remains the only spacecraft to have visited Neptune. During its flyby in August 1989, it provided invaluable data and stunning images, including the discovery of Neptune's rings, identification of 6 new moons, detailed observations of Triton's surface and geysers. Future missions. While there are no confirmed missions to Neptune, scientists have proposed sending orbiters or probes to explore the planet and its moons further. A dedicated mission would shed light on the planet's atmospheric dynamics, interior structure, and the mysterious properties of Triton. Seasonal variations and long year. Neptune's axial tilt of 28.32 degrees is similar to Earth's, causing seasonal changes. However, due to its 165-year orbital period, each season lasts over 40 Earth years. This slow progression provides scientists with unique opportunities to study long-term atmospheric changes. Mysteries and scientific importance. Internal heat source. Neptune radiates more heat than it receives from the Sun, suggesting an internal heat source. The mechanism behind this phenomenon remains unclear and is a subject of intense study. Magnetic field. Neptune's magnetic field is tilted and offset from its rotational axis, possibly due to complex movements within its fluid interior. Formation and evolution. Understanding Neptune's composition and dynamics offers insights into the formation of the solar system, particularly the outer planets and the Kuiper belt. Conclusion. Neptune remains one of the most intriguing objects in the solar system. Its extreme weather, mysterious interior, and dynamic moon system continue to challenge our understanding of planetary science. With advancements in telescope technology and the potential for future missions, Neptune promises to reveal more secrets about our cosmic neighborhood. Let me know if you'd like details on a specific aspect such as its moons, rings, or atmospheric phenomena. If you like our videos, please support us with a thumbs up, subscribe to our channel Digital Discoveries, and look forward to the videos that will be waiting for you in the future.